Hey class, I'm back to show you guys some examples. All right, so here's a situation just like our lab that we completed today. This is for B period. All right, so we have these two masses, mass 1 and mass 2, connected by a string. In this problem, though, there is no friction, so you don't have to worry about that. And I kind of just wanted to talk through this example with you guys. All right, so the first thing you got to do is create the free body diagram. So for mass 1, we have the force of gravity 1 pointing down, force of gravity 1 pointing down, we have tension, and we have normal force. For mass 2, it's just force of gravity 2 and force of tension. And keep in mind, these two tensions are the same value, all right? Just one is pointing with the acceleration, and one is pointing against it, all right? And then we are given that the mass of mass 1 is 0.5, mass 2 is 0.25, and we're looking to solve for acceleration and the tension. So the first thing you gotta do in a situation like this is you set up an equation called F net equals MTA. Now, the reason why you use MT is because you want to use the entire system, moving as one unit, all right, one unit. So our F net in this case is just going to be the force of gravity 2, because force of gravity 2 is the reason why mass 1 is able to accelerate to the right and mass 2 is able to fall down. All right, so that's very important. All right, so force of gravity 2 is our net force. The mass of the system is going to be mass 1 plus mass 2. All right, mass 1 plus mass 2 times acceleration. So then from here, you just plug in all the values. So force of gravity 2 is going to be 0.25. That's mass 2 times 9.8. That's gravity. Plus the total mass, 0.5 plus 0.25, times the acceleration. You manipulate the situation. A is equal to 2.45 divided by 0.75, and this is your acceleration. All right, so you get an acceleration of 3.27 meters per second squared. All right. Now, when you're solving for tension, we talked a little bit about it today, but we have to isolate the free body diagram. All right, so we have to isolate the free body diagram. So I'm isolating the one that's hanging, right, because it's a little bit easier. So we have F net equals M2A. M2 is allowing me to isolate mass 2. So that means I'm only looking at mass 2. So we have force of gravity 2 minus tension equals M2A. All right? All right, so to continue on, we have, we're isolating mass 1, or mass 2, sorry. So we have force of gravity 2 minus the tension equals M2A, and we're solved for tension, and we get Ft is equal to 1.63 newtons, just like what we did today. Now, the only difference between the lab problem that we had and this problem is that there is no friction. There's no friction in this problem, so you don't have to worry about that. All right, so the next example I want to go about friction. So in this problem here, we have a 30 kilogram block, all right, sitting on a table. It has a coefficient of kinetic friction of 0.25 and a coefficient of static friction of 0.35. Now, the three questions I have: how much force is required to get the box to move? Or that question is phrased wrong, but how much force is required to get the box to move? How much force is required to keep the box moving at a constant velocity of 5 meters per second? How much force is required to accelerate the box at 2 meters per second squared? All right, so question 1, the force required to get an object to move is actually equal to the maximum amount of static friction. So remember how I said about static friction, how it builds to a maximum point, right? So in this example, right, to get it to start moving, the force applied has to equal the force of friction static, the total amount. So force of friction static is the coefficient of static friction, mu s, times the normal force. So mu s, that is the coefficient of static friction times the normal force. So you just do, and the normal force is calculated by 30 times 9.8, and you get 294 newtons. And then the force of friction static is going to be 0.35 times 294, which is just equal to 103 newtons. So our force applied is 103 newtons. So that means it requires 103 newtons to get the object to start moving. All right. Question 2, it says, how much force is required to keep the box moving at a constant velocity of 5 meters per second? Now, I give you guys a velocity, but that number is actually not important. It's there. I put it there because I wanted you guys to be thrown off. it's important that you think, like, I want you to think about it, but the really important fact is the constant velocity. Because constant velocity is, again, an equilibrium situation. So to get the object to move at a constant velocity, the force applied actually equals the force of friction kinetic. So you just have to calculate the force of friction kinetic, which is going to be 0.25 times the normal force that we already calculated from the previous problem, and we get 73.5 newtons. So our force applied is 73.5 newtons. All right, and the last part, how much force is required to accelerate the box at 2 meters per second squared? All right, so this time, now we are accelerating. Now we're doing Newton's second law, F net equals ma. Our F net in this situation is going to be the force applied minus the force of friction kinetic is equal to mass times acceleration. All right, so you have force applied pushing it to the right, force of friction kinetic is left, and obviously we want the force applied to be bigger, so it's accelerating the object at 2 meters per second squared. You manipulate it, solve for FA, and you get an FA of 133.5 newtons. All right, and again, the force of friction kinetic stays the same, 73.5, because that number right there, that's specific to this problem. So the force of friction kinetic will always be 73.5 for this specific problem. All right, it would not change. So if the acceleration was increased to 5 meters per second squared, the force of friction kinetic is still 73.5. If the acceleration turned to negative, the force of friction kinetic is still 73.5. So that's very important. All right, and the last thing I wanted to show you guys, I wanted you to try this example here. So copy this down, pause the video, do what you have to. But in this situation, I'm giving you a situation where you have a force applied at an angle of 37 degrees with a coefficient of kinetic friction. So this object is moving. So what I want you to do is draw the free body diagram, calculate all the forces, and then calculate the acceleration. All right, we will probably go over this problem on Friday. So good luck, and I'll see you Friday. Bye.